So this is the Leaving Certificate Ordinary Level 2023, Paper 1, Question 2. So it says here, in this question, I squared is equal to -1, which is perfect, okay? So straight away that implies that we're using complex numbers. The complex number Z1 is shown in the Argand diagram, and we should know that the Argand diagram is this diagram here, where we've got our real numbers and we've got our imaginary numbers, okay? It says plot and label the conjugate of Z1, the complex conjugate of Z1 on the Argand diagram, okay, or on the diagram above. So it gave us this diagram here. We could see Z1 was here. So what we did is we looked at what Z1 was and we looked at getting the conjugate. Now, anytime you're looking for the conjugate of complex number, all you do is just change the sign of the imaginary part. So that changed from a negative to a positive. Okay, and you can see you've got the exact same number. They're both Z1, 3 minus 3i. So this is coming across 3 and down 3, so it's 3 minus 3i. And the complex conjugate is going to be when we change the imaginary part from a negative to a positive. Okay, so all we do is we take the imaginary part, we change it from, if it's a negative, we change it to positive. If it's positive, we change it to negative. In this case, it was negative, so we changed it to positive. So 3 plus 3i. So we're coming across 3 on the real and we're going up 3 on the imaginary. So you can see there, the complex conjugate of Z1 is going to be just here. Okay, so we've plotted and labelled it. It also gave us 2 points there. You can see we've got Z2, which was 5 plus I. So 5 plus I is here. So if we come across 5 and we go up 1i, it brings us up to here. So that's where Z2 is. If it just says I, that means 1i. So we're coming across 5 and up 1. And we've got 6 minus 2i. So again, if we're thinking this as if we were doing coordinate geometry, it's 6 and it's minus 2 on your y. So we come across 6 on the real and we come down 2 on the y. And we can label that there as Z3. So 6 on your real and minus 2 on your imaginary. That brings us on to the next couple of parts. So let's see, so plot and label we've done. It now brings us on to part 3. So it says, write 4 times Z2 minus 5 times Z3. Okay, so 4 times Z2 minus 5 times Z3. So let's go back up and look. We have our Z2, we have our Z3, and we can fit them in there. So 4 times Z2, and you can see there Z2 is equal to 5 plus I. So instead of saying Z2, I'm just going to put in the 5 plus I. And instead of saying Z3, I'm just going to put in the 6 minus 2i. So this expression here is, this expression is the exact same as this here. The only difference is that I filled in the value of Z2 and Z3. The next thing that we need to do is we need to be able to expand. So 4 times 5 gives us 20, and 4 times I gives us 4i. Minus 5 times 6 gives us minus 30, and minus 5 times minus 2i, a negative by a negative will give us a positive, and 5 times 2i will give us 10i. Just designing on that, most people would make a mistake there with their signs, so do be careful. A negative by a negative is a positive, and then 5 times 2i gives us 10i. The last step there is just to add your like terms. So we need to look at our numbers. So obviously 20 take away 30 leaves us at -10. And similarly, plus 4i plus 10i gives us plus 14i. So this brings us on to part 4. So part 4 said, work out the value of the modulus of Z3. Give your answer in third form. Okay, so third form just means leave your answer as a square root or whatever it may be, right? So the modulus of Z3, you should be familiar with these symbols. You've seen these lines before. You've seen these in coordinate geometry. So normally you've seen that when they ask for the length of a line. So if it was the length of a line, say for instance, it was the length of the line AB, you would have the length of the line AB, something like that, okay? So what this means when we're looking at complex numbers, what it means is you're looking for the modulus of a number. So a modulus of a number just means the length of a line. You've got your point there, Z3, and the modulus, what the modulus means is find the length of the line, Z3, and it links it the whole way back as far as the origin. Okay, so anytime you're looking for a modulus is always from 0, 0 to wherever your point is. And in this case, our point is here, which is 6, negative 2. Okay, so in order to find that, what I've done is I've drawn it out here graphically. So you knew that you were coming down 2 units. You knew you were coming out 6 units. Now, obviously, this is a negative 2, but in terms of this triangle, it's 2 units. Okay, so we've got 2 units here, we've got 6 units here, and we're looking for the length of this side here. Okay, so when we're looking for the length of a line, we know we've got a right angle triangle. So if we've got a right angle triangle, we can use Pythagoras' theorem. Okay, so Pythagoras' theorem says that a squared plus b squared is equal to c squared. C squared is always the hypotenuse. So c squared has to be opposite 90 degrees. So c squared has to be x squared. Okay, so it has to be opposite 90 degrees. It has to be x squared in this case. A and b, it doesn't matter which one we label A or which one we label B. In this case, I just went from left to right and labelled A as 6, and I put 6 in, and I labelled B as 2. Okay, if you put them the other way around, it would make no odds because you're adding them. So 6 squared plus 2 squared is the exact same thing as 2 squared plus 6 squared. So in Pythagoras' theorem, the only thing that matters is that you've got your hypotenuse always opposite 90 degrees. Okay. From here, we formed an equation. To solve this equation, we just squared the 6 to get 36. We squared the 2 to get 4 is equal to x squared. That's fine. We added our two terms together. 36 plus 4 gave us 40 is equal to x squared. And then in order to find out what x is, we needed to get the inverse of x squared. So the opposite to x squared. Now, I've said this to you before. The opposite to plus is minus. The opposite to divide is multiply. The opposite to times is divide. The opposite to square is what we call the square root. So if we get the square root of this side here, and I'll just type that in there so you can see, you'll be left with x. But because we're getting the square root of the right hand side, we have to get the square root of the left hand side. So you can see there, if we get the square root of this, we're left with x. If we get the square root of this, we're left with the square root of 40. And if you type that into your calculator, the square root of 40 will give you 2 root 10. Okay, so that brings us on to the last part of that question there. And you can see that it talks about the modulus of each of these lines. So which one of these has the largest modulus? So it's asking you which one has the largest modulus, and you know yourselves that the modulus is from 0, 0 to, for instance, z7. So if we were looking for the modulus of z7, it'd be the length of this line here. Okay. If you're looking for the modulus of z4, it'd be the length of this line from z4 back as far as 0, 0. If you're looking for the modulus of this one here, it'd be from 0, 0 over as far as z6. And similarly, if you're looking for the modulus of this line here, it'd be from 0, 0 down as far as z5. So just from looking at the question, you can see there, I've ticked z5. Z5 seems to be the furthest point away from 0, 0, and the furthest point away from 0, 0 is what we will take as the largest module. So the largest the largest modulus is from 0, 0 as far as z5, and the reason for that is it's the furthest point from 0, 0. And that brings us to the end of question 2.